Thanks for watching my video. Today I'm going to discuss the chain rule in derivative. Okay, I'm going to discuss step by step. So when is a function is said to be differentiable? Okay, a function is said to be differentiable at a function is differentiable at point, let's say A. Okay, it is differentiable at point A when its domains of limit, and then is right hand limit, left hand limit f of a plus h minus f of a over h. This is left hand derivative is equal to right hand derivative. If left hand derivative and right hand derivative are equal and finite, then at that point A we say that this is differentiable. Okay. Now the chain rule states that if fu is differentiable at point u equal to g of x, okay, and g of x is differentiable at x again, there are two things, then the composite function f naught g of x is equal to f of g of x. Then is f naught g of x is equal to f of g of x is differentiable at x, and f naught g, this is derivative of x, is equal to f dot g of x into g dot x, and Leibniz denote this in a Leibniz, according to Leibniz notation, y is equal to f of u and u is equal to g of x. Okay, I'm going to prove the chain rule. Okay, from this then from derivative definition we know derivative of this one, what y plus delta y will be what f of u plus delta u. So delta y is equal to what f of u plus delta u minus this transfer here minus y is f of u. Okay, this is one part, and this one u plus delta u is equal to g of x plus delta x. Then delta u is equal to g of x plus delta x minus u, if you transfer minus, okay, u is g of x. From this we are going to derive. So taking this one, okay, from that one delta u is equal to g of x plus delta x minus g of x, and you should know that delta x is not equal to 0. Okay, if it's equal to 0 mean delta u will be 0. Okay, that what we don't want. And again in y, this one delta y is equal to f of u plus delta u minus f of u. Okay, now if I divide delta y by delta x, okay, this can be simplified as what delta y by delta u into delta u by delta x. Okay, these two we cancel also, same thing. And now taking limit as delta x tends to 0 mean delta u also will be tends to 0. Okay, now therefore we take the limit delta x tends to 0, delta y by delta x is equal to limit delta x tends to 0 delta y by delta u from properties of limit delta x tends to 0 delta u by delta x. Since delta x tends to 0 and delta u also tends to 0, so limit delta x tends to 0 not delta y by delta x is equal to limit delta u tends to 0. Since delta x tends to 0, so delta u also tends to 0 delta y by delta u into limit this is same thing, so delta u by delta x. Okay. Now we know this is what derivative of y with respect to x, and this is derivative of y with respect to u into this is derivative of u with respect to x. So this one, okay, this is what we call a chain rule.